Reminder, there's no quiz to work on this week. I still need to finish grading your exam. We're doing notes for homework 10. Okay, so the topic for this homework is radicals. We looked at, last class, I think we talked about x with the power 1 over n. Now we're going to talk about x with the power m over n. It's just the same idea, but expanded. From in general, if x is a non-negative real number, m is an integer and n is a positive integer. X with the power m over n can be written as the nth root, so whatever number's in the denominator will be your root. And you can put that numerator as the power on x, and it can, let's see, like this, x with power m. This is one way to rewrite this fractional exponent. I think it'd be better to say this rational exponent. Another way you could do it, and this is definitely the best version to use if you're trying to simplify a number that has an exponent like this, is to keep that denominator as your root, still an nth root of x. But instead of that power under the root, we're going to put it outside, like this. So this is the nth root of x to the power m. So again, the denominator is always going to be the root either way, but the numerator can be the power under the root or the power outside of the root. So we already saw something like this earlier. It's similar to the other result with x, and it had a power 1 over n. And we wrote the nth root of x. And that power of 1, you could put on x under the root, which x to the first is still x. Or you could put it outside of the root. Keep n as your root, the value in the denominator, and then x, and this all has a power of 1. So this matches that result right there. But when we wrote it in our last class, we left out the power of 1 because x to the first is still x. Same for this part. We left off this power 1. Since the nth root of x to the first is still the nth root of x. Let's look at something more specific, like we'll put x to the 3/4 power. The denominator is the root. It's a 4th root of x cubed. We're going to have a to a power of 5/6. Denominator is the root. It's the 6th root of a. You can put the power of 5 right here or out here. I'm going to put it under here. It's correct either way. Okay, got 9 and it has a power of 3/2, and you're going to work this out in scratch work. I can take 9 with the power of 3/2 and write the denominator as my root, square root of 9. And instead of putting that power under the root with these numbers, it's better to use the other version where you put the power outside. Like after we find the square root of 9, then we'll cube that number. This is my suggestion. It's correct either way. Okay, square root of 9. You've got 3 times 3 is 9. When you have as many factors as the root, that factor can come out of under the root. So that's just 3. Then we're going to cube it to get 27. Okay, so before we do more examples, which I've got a lot of examples planned, we want to talk about, excuse me, we want to talk about how to know that your radical is simplified. There are 3 things to look for. You need none of the factors of the radicand, what's under the radical, to be able to be written with a power greater than or equal to the root. So we'll practice this one for sure. I did the experiment. None of the factors of the radicand. The radicand is everything under the root symbol. Can be written with an exponent that is greater than or equal to the root. And then the second one, we're going to focus on problems that we can work with for this part. You have no fractions under the radical sign. So if you do have a fraction, you want to use the rule for radicals that was for division. So you would kind of split up that fraction and then simplify the numerator and the denominator. And you would maybe need to rationalize the denominator, which is part 3, but we're not going to go that far in this class. I did in the past, but we don't have time for the focus of this semester. So something we could do, but we're not going to, is rationalize the denominator. At least this is what I remember it being called, but I'll write out what I mean. It's so I'm pretty sure it's to rationalize the denominator. It means to write your expression without any radical signs in your denominator. So no radicals in the denominator of a fraction. Okay, we're going to focus on problems in which we don't have to rationalize the denominator. So we're going to skip this kind of problem in this class. So I'm going to note that this will not be on your, not on the homework, not on the test. That's just number 3, just this part where you have a radical in the denominator. We're not going to go over that, but we are going to take care of fractions, and we're going to take care of anything that has a power greater than the root. So I'm going to start with questions like that. So each one of these is going to just ask to simplify. And when you simplify a radical, we have powers of the radicand less than or equal to less than the root. We have no fractions under there, and we have no radicals in the denominator, which we're not going to look at today. Let's do just a root 7. for the root of 7. It's a square root, so the root is 2. And the power on 7 is 1. So the power 1 is less than or equal to the root of 2. So this is simplified. Now we've got square root of 8. So your root is 2. Under here with 8, we're going to factor. It's 2 times 2. It's 2 times 4, which is 2 times 2. So it's the square root of 2 cubed. So we're not simplified yet because that power of 3 is greater than or equal to the root of 2. So we need to keep going. And the way I look at this is if you have as many factors as the root, you can bring that factor out. Or we can write down all the exponent rules, but it just saves me time to see that I've got 2 2's right here. So this factor comes out of the root. Under this square root, we leave behind this factor. So there's a root 2 root 2. Okay. To simplify the square root of 1/4. Part of the problem is there's a fraction under my root. So, and I can't have any fractions under the root, or else it's not simplified yet. So we'll take the root of 1/4 and use the rules for roots were for multiplication or division. So we're using the rule for division. The root of 1 divided by 4 is the root of 1 divided by the root of 4. You can write this square root of 1 squared. And this is the square root of 2 squared. So another way I've seen some students do this is once you've got that power that matches the root, they kind of cancel it out, like they undo each other, and what's left is 1. And here, this power, this root 2 and this power 2, leave that 2 right there. I got 1 half. Okay, we're on to, I've got a cubed root of 48. Okay, so I start factoring these. 48 is 2 times 20. 24 is 2 times 12. It's 2 times 6, and 6 is 2 times 3. So the cubed root, the way I usually kind of talk through this with someone is to find 3 of the same factor. 1, 2, 3 2's. So I can bring out a 2. Underneath the cubed root is this 2 times that 3. So we need that 6 to stay under the root. And we needed to do that because if we had written this factor 2 with its power of 1, 2, 3, 4, that power would be greater than or equal to the root. So it wouldn't be simplified yet. This time we have a square root of 125 xy cubed. Okay. So just to be clear, when there's no root, it's a root 2. Put that in that blank space, and I would start to factor 125. Okay, this would be 25 times 5. 5 times 25 is 125. You can think of it like quarters. If you have 5 quarters, you'd have 125 cents. Okay, 25 is 5 times 5. So with my root 2, I can take out a factor if I've got 2 of them. So since I have 2 5s, I can bring out the number 5. But this 5 needs to stay under the root. And this x, let's see. I'm going to start to put the answer together on this side. And maybe we'll write out what we've got so far. We would have 5 cubed times y cubed. So saying one way to think of this is you can take out a number if you have as many factors of that number as the root. So you can bring out this 5. Under the square root, we need to keep that 5. X has a power of 1, which is less than or equal. This is less than, strictly less than the root. So that part's going to just stay under here. Y cubed, you could look at it as y times y squared. So that power and that root and that power will undo each other. And you can bring out this y, but that y has to stay. This stays under the root right here. And this comes out of the root right there. It's all multiplied together. I'm going to try to talk through this in a different way. So sometimes I've worked with a person who's noticed that you can divide the root into the power. And it's like say 3 divided by 2 is 1 with the remainder 1. So you can bring out 1 5 and the remainder stays. There's another 5 that stays. This is already simplified, it just gets rewritten. This, we can take the power 3, divide by 2. You get 1 with a remainder of 1. So you can bring out 1y, and the remainder has to stay. That one other y has to stay. Okay, let's try to go through that with a different problem. Okay, we're gonna do this. It's a cubed root. We're gonna go with 80. Let's do A, and it has a power of I'm gonna do 6. Then B with a power of, let's see, 17. Okay, let's start with just getting this copied down and we factor 80. We can do 8 times 10. 8 is 4 times 2. 4 is 2 times 2. Over here, 10 is 2 times 5. So 80 would be 2 times 2 times 2 times 2 times 5, which we'll copy over in just a second. But I'm going to stay here, and just one way to look at this part is we can write it as a cubed times a cubed. And I'm doing that just because I have that root 3. And I want powers that match the root. Or we could have done a cubed, and then that with the power 3 would be the would get us to the same answer. Okay, B, we can look at we're going to do what I want to do is talk about how if you divide this number by the root and then have a remainder. So if we did 17 divided by 3, or if we did, how many times could 3 go into 17 evenly? Like 5. 3 times 5 is 15. So b to the 15th times b squared. Okay, I know this is getting pretty messy, but we'll rewrite it in a second. B to the 15th times b squared, we could put as b to the 5th and then cubed times b squared. All right. The reason why I did all of that is just to get that root 3 to match that power 3. And I'll be able to bring out b to the 5th, but the b squared is going to have to stay. Okay, so right now we're just copying down the problem, but we're going to write 80 in its factored form, which was 2 to the 4th times 5. It's 8 to 6. Okay, so as far as the number part goes, if I'm working on scratch paper, I would think I've got a root 3. If I have 3 of the same factor, I'll bring that number out of the root. I have 2, 2, and 2. Since I have 3 2s, I'm going to bring the 2 out in front. Then this 2 times this 5 has to stay underneath the root, the cubed root. So here I've got a root 3, and that power 3 gives me this a, and a root 3, and that power 3 gives me another a. So I've got a times a outside of the root. And then from the way I've worked out b to the 17th, the first part, b to the 5th cubed, that power 3 and that root 3 would undo each other, and you'd bring the b to the 5th out. Let me screw this up. Okay, but the b squared has to stay under the root. So what we have so far is 2a squared b to the 5th, and then the cubed root of 10b squared. Okay, we're going to talk through this one more time. Just using experience I've had working with students in class. So I've talked with someone before where they take that power, divide by the root, so 4 divided by 3, gives you 1 with remainder 1. So you can bring out 1, 2, but another 2 stays under the root. Okay. This power on 5 is already less than the root, so we just leave a 5 underneath. So there's a 2 times 5 under the root. Then we move over to a. It has a power 6, divide that by 3. It divides evenly. You'd have 6 divided by 3 is 2. So we're going to bring out a squared. And then take that 17, divide by 3, and see what the remainder is. So 3 can go into 17 5 times. That's where we got the b to the 5th, with remainder 2. So b squared stays. Let's try another one like this. Now, what we're going to do a square root of 64 x to the 8th, y to the 11th. Just copy down the bottom. If you have your own way of thinking through simplifying radicals, you can use your own tricks, but I'm just doing my best to explain how to simplify this using like past experience. For me, it's easiest to just start a factor tree on the number. So I'd factor 64. Let's go with 2 times 32. 32 would be 2 times 16. 16 is 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. Okay. It's a square root. So I'll be able to bring out pairs, or if I have 2 of the same factor, I can bring that number out. So I'll bring out a 2 and a 2 and another 2. So out of the radical, we'll put it on the board on the side in a second. We'll have 2 times 2 times 2. And then for x to the 8th, I could do exponent rules and make this x to the 4th and then squared. And that way the power here will match the root there, and I'll bring out x to the 4th. With y to the 11th, I want to try to write this in a way so that I can have 2 divide into 11 and then have the remainder as a separate piece. So 2 can go into 11 5 times. And that would be 2 times 5 is 10, y to the 10th with remainder 1. Okay, and on this part, y to the 10th, I want to have some kind of power of 2 to match the root of 2. So I can make this y to the 5th squared. Times y. So what I'll be able to do is get this 2 and that 2 to undo each other, bring out y to the 5th. You can't see it all. But the extra y right here has to stay. Okay. So right now I'm just copying down the same problem, but with 64 factored. So 64 is 2 to the 6th. Okay, so I said earlier, we're going to bring out a 2, multiply it with that 2, multiply it with that 2, and we'll have 8. 8 outside of the root. Or let's see. Let's do 2 times 2 times 2. Times. Right here, we had the root 2 and the power 2 give us x to the 4th. And for this part of y to the 11th, we can have that power 2 match the root 2 and bring out the y to the 5th. But you need to leave that extra y under the root. So we didn't leave any 2's behind. We didn't leave any x's. All that's left under here is a y, and it's a square root of y. Okay. want to talk through this again, but without using any of all the factoring and, I mean, we do use factoring, but without doing the like grouping together or the exponent rules. We're just going to look at dividing the power by the root. If there's a remainder, you need to leave that value under the root. Everything else comes out of the root. So let's see. For 2 to the 6th, take the 6, divide by 2, which would be 3. So we have a 2 cubed left over. For x to the 8th, take 8 divided by 2, which would be 4. That's where we get x to the 4th. Take 11, divide by 2. It doesn't divide evenly. What you can get is 2 goes into 11 5 times. That's our y to the 5th. With 1 left over. That one extra one has to stay under the root. Okay, let's see what's next. Cool. So we're going to look at this problem. I'm going to make this 18 and we're going to put it over 100. Cool. So first of all, we have a problem with having a fraction under the root. So we're going to take care of that right away. Then we want to simplify the values under the root by factoring, like we'll factor 18, then we'll factor 100. Well, actually, we could even reduce this fraction first and then keep working. We're going to do this. We're going to take 18 over 100. And have the root of 18 over the root of 100. Okay, factor 18, we could write it as 9 times 2. And let's write 100 as 10 squared. That way I can have a power of 2 and match that root 2. Okay, actually, we're going to use a product property. So technically what you would really like to be a little bit more precise or to really follow the rules, we would want to next take the root of 9, multiply it with the root of 2. When I've got that square root of 10 squared, it leaves 10. So I've taken care of having a fraction under the radical, and luckily, I don't have any radicals in the denominator. Okay, the root of 9 is the root of 3 squared. We have a root 2, so it's all over 10. Square root and that power 2 gives us this 3 multiplied with the root 2 is over 10. Okay. Going back over here, if it was just some scratch work and you're, just trying to quickly get an answer, for me, I would just I would keep this whole root here factor 9 with the factor tree, which I'll do this way. 3 times 3. Since it's a square root, if I have two of the same factor, I can bring that number out. I have two 3s, this 3 and this 3. So I can bring it out of under the root. But this 2 right here has to stay underneath the square root. Okay, let's do it's a cubed root of negative 40, a to the 5th, b to the 12th. Okay, this is start with copying down the problem. And then factor 40. Do 2 times 20, 2 times 10, which is 2 times 5, and I'm done. So since I have a root 3, if I have 3 of the same factor, that number comes out of the root. I have 3 of the factor 2, so I know I'm going to bring 2 out, but leave this 5 behind. No, we're going to put it on the. All right, we're going to stay here, and I'm going to do some scratch work where we talk about exponent rules and how that helps us simplify the problem. But then I'm going to talk through the trick that we were doing earlier with dividing the power by the root and having a remainder. Okay. A to the 5th could be a cubed times a squared. And it picks the a cubed to match that root 3. So that's why I split it up this way. Oh, luckily 3 does go into 12. So I could write this b to the 12th as b to the 4th to the 3rd. And again, I'm picking this power 3 out here to match with that root 3 that I was given. So I'll be able to bring out an a, but the a squared stays, and I'll be able to bring out b to the 4th, and there's no leftover values for b under the root. Okay, let's start though by just rewriting what the problem is with the factored form of negative 40. And actually, when there's an odd root, you can bring a negative sign out from under the root. So with the cubed root, let's take this negative out first. The cubed root. 40 is 2 to the 3rd times 5. A to the 5th, b to the 12th. Okay, so we copy down the negative sign. And then that root and that power match, so we can take out 2. We're saying here, I've got 3 of the factor 2, and I've got root 3, so that factor comes out. But 5 has to stay. A to the 5th. We're going to go over here first. And for this a cubed with that cubed root, we'll get a. The a squared stays under the root. And then the b to the fourth cubed, that power 3 matches that root 3, so we can bring out the b to the fourth. And there aren't any other values of b under the root, so we can maybe erase a little bit. Okay, so that's our answer. -2 ab to the fourth times the cubed root of 5a squared. And then we're going to talk through it one more time, looking at dividing the powers by the root. So if you take, again, when it's an odd root, we bring out the negative, start there. Then for 2, it has power 3. 3 divided by 3 is 1, so we bring out 1, 2. 5 has a power less than the root, so it just stays under there. A to the fifth, we take 5 divided by 3. 3 goes into 5 2 times with the remainder of 1. So we can bring in, wait, sorry, that was wrong. 3 goes into 5 once with a remainder of 2. So you can bring out 1a and leave 2 behind. Okay, 12 divided by 3 is 4, so I'm going to bring out b to the fourth. No remainder, so nothing left over underneath the root. Okay, so in the next one is, this is kind of a problem I made up for fun. A little bit is that I want you to watch out for tricks, but also just because we've learned how to factor, we can mix that with radicals. Okay, so we simplify a square root of x squared minus 2x plus 1. So even though you don't really have a problem like this on your homework, or it won't be on your test, I just want you to know or remember there aren't any rules for radicals that involve subtraction or addition. So we're not going to break this up into 3 pieces, and we do not have an x right here because of that minus sign right there. But what we could do is try to factor this whole part under the radical. So factor x squared minus 2x plus 1. So again, I don't even want to write it on the board because I don't want it to sink in or anything, but we don't have an x right here because of this sign right there. If there's a minus sign, you need to stop and see what to do if there are other tricks to use. Like that. If you have a way that you like to factor, totally cool. I like my style, which is the grid. I put my x squared negative 2x and a positive 1. Separate like this, and here you get 2 numbers that multiply to x squared, x times x. On this side, you need 2 numbers that multiply to 1, but also after you cross multiply, you need the sides to add to negative 2x. So to save some time, I'm going to go ahead and jump to negative 1 times negative 1 is positive 1. And if I go across, I'll have a negative x. Add to x times -1 is negative x. And when you add the sides together, there's a -2x. And if you get a matching value to your middle term, then the factors are the top row multiplied with the bottom row. Okay, the radicand in this problem, which is x squared minus 2x plus 1, factors into x minus 1 times x minus 1. So our radical, let's go. Is the root of x squared minus 2x plus 1 would be x minus 1 times x minus 1 under the root. So you've got a root of x minus 1 squared. And it's a root power 2 and a root 2. So this will simplify to x minus 1. And that comes from factoring. Okay, so we just keep on doing examples until we feel like we understand or until we run out of time. Okay, we want to take negative 16 to the power of -3/4. Just copy this down. 16 -3/4 power. And the very first thing I would take care of is the negative sign in your power. So to take care of that negative sign, we'll put all of this under 1 or down into the denominator. So 1 in the numerator, 16 with the power of +3/4 in the denominator. Okay, so I've gotten rid of the negative sign that's in my power by shifting everything down to the denominator. Next, what I would do is rewrite that fraction power, or that exponent that's a fraction, as you need your denominator to be the root, so a 4th root. And I'm going to put the power on the outside of the root. So there's a 1 in the numerator. We're working on this part here. We take 16, give it a 4th root. And the power 3 could go under the root or outside. I think it would be easier to explain if we put it outside. But you'll get the same answer either way. So it's fine if you put it under or out. Either way is fine. Okay, we're going to factor 16. It's 2 times 8, which is 2 times 4, which is 2 times 2. So I have 1, 2, 3, 4 2's and a root 4. So I'm going to bring 2 out of the radical, or we can write this with some exponent rules. Okay, right now we're at 1, and it's over the 4th root of 2 to the 4th. And then after that, we're going to cube everything. We still have 1 sitting in the numerator. This root 4 and that power 4 will simplify this part to 2, and then it's going to be cubed. And 2 cubed is 8. Okay. So let's put some negative signs. We're going to do a -8. To the negative. Let's just do 1/3. I kind of want to do 2/3, but I don't, let's try 2/3. Let's see what happens. We're copying down the problem. The first thing I'm concerned about is the negative sign in my exponent right here. So that was what I would do first, take care of that part. And we're going to get rid of this by putting all of that underneath 1. So we put 1 in the numerator, bring this all down to as -8 with a power of positive 2/3. Okay, so we've got a 1 over. We're going to take the denominator and make that our root. So it's a cubed root of -8. And the numerator of 2, it can be under the root or outside of the root. You can pick either one. I just like to put it on the outside. And that way I can take care of it later. I can like square all this stuff once I've taken care of that part inside. Okay, let's keep going. When you have an odd root, you can take a negative sign out from under the root. So we'll bring this negative out and have a negative cubed root of 8. Okay. I think we factored 8 a few times, but we can always factor it again. It's 2 times 4, whereas 2 times 2. So since I have 3 of the factor 2 and a root 3, that 2 is going to come out from under the root. Or you can write some exponent rules like this. We've got the 1. It's over a negative cubed root of 2 cubed. And then we're going to square it. So you can think of it like that power and root undo each other. this 2 was left, and the negative sign applies to it. So it's a negative of 2. And then squared. One over positive 4. Okay, I'm going to do a couple more examples, but we've basically gone through enough to help you with your homework. Kind of thinking of, let's play around a bit with negative signs. So okay. We'll do this first. We're going to try same number of negative 8. And put it to a negative 3/4 power. So just copy down the problem. And the first thing I'm concerned about is the negative sign that's in the exponent. This one right here. So I would just put all of this under 1. And then the negative 8 has a power of positive 3/4. We're at 1 and it's over negative 8. And you use the denominator as your root, so it's a 4th root. You can have negative 8 cubed, or you can have all of this cubed on the outside. And then we're stuck because you have an even root of a negative number. So since this part right here is not a real number, this whole expression is not a real number. It's a complex number. So if we were in a class that did use the complex numbers, we would write this with an imaginary part, and then we would be able to write this. We could simplify this further, but in the complex numbers, we're stuck in the real numbers and don't go any further. Okay, I'm gonna try one more. And I'm going to make it kind of tricky on purpose, and then we're probably done for today. So let's take some kind of fraction and put it with a negative power that's also a fraction. To make this not too crazy, we're gonna leave numbers out and we're just gonna do something like let's put x to the 6th over y to the 10th. And we'll do a power of -1/2. So this negative sign is the first thing to take care of. Yeah, problem. So we need to put 1 over all of this, but then we can have a power of +1/2. So you've got 1 in the numerator. It's over x to the 6th, y to the 10th. And that has a power of 1/2. I'm gonna do next is just for practice really, is I want to change that 1/2 power to a square root instead. So we still have a 1 sitting in the numerator. And instead of 1/2 power, we have a square root, or take 2 as your root. And you've got your x to the 6th over y to the 10th. And you can put power 1 on this, but it's still the same number. You could put power 1 on the outside, but it's still the same number. So we're going to leave that part off. Putting the denominator as your root, but putting the numerator as your power doesn't change the value, so we don't need to write it down. Okay, so we have a problem. There's a fraction under the root. We can't have any fractions under the root, so we're going to split this as a root of x to the 6th and the root of y to the 10th. And to keep it all kind of organized, we'll put big parentheses. Still have 1 over. Let's talk about the root of x to the 6th. So I'm going to do that trick we had before of taking that power 6, divide by 2, and you get 3. So what's in the numerator of this part is x cubed. And then for the denominator of what's in the parentheses, take that power 10, divide by 2, and you get 5. So y to the 5th is in the denominator. Okay. And then to help with the next step, what I'm going to do is take 1 and write it as 1 over 1, just to make this. Or you know what? We can leave 1 how it is. 1 is just 1. We take that top value and multiply by the reciprocal of the bottom value. So just thinking of like a fraction divided by a fraction. But you can take a number divided by a fraction is to have that number multiplied by the reciprocal of the bottom fraction. Okay, we're almost done. We've gotten to this number in the numerator, 1, times the reciprocal of what's in the denominator. So y to the 5th over x cubed. Which would be y to the 5th divided by x cubed. Oh, and we're out of time. So thank you for coming to class. Please work on your homework and have a good weekend.